Hello friends, welcome to the PS Concepts channel. Today I have bring with the de Broglie equations in the continuation as earlier discussed with the topic Young's double slit experiment. So here is the important concept regarding to the uh, electrons wave nature. So in 1924, Louis de Broglie proposed a revolutionary idea in his PhD thesis. Researchers Sir Le theories this quanta, building upon Einstein's concept of photons or light quanta. De Broglie extended the particles of wave-particle duality to all matter. He suggested that not only light but every particle from electrons to atom could exhibit both wave-like a particle-like behavior. This bold hypothesis was confirmed experimentally just a few years later. In 1927, the Davison-Germer experiment demonstrated electron diffraction, providing direct evidence that matter can behave like waves. For this groundbreaking contribution, de Broglie was awarded for Nobel Prize in Physics 1929. His insight laid the foundation the modern quantum mechanics, Schrödinger wave equation, and indeed much of quantum theory rest upon de Broglie vision of the matter waves. Today, this concept continues to shape our understanding of the microscopic world, from atomic orbitals to advanced technology like electron microscope. Louis de Broglie hypothesis tells us that every particle has an associated wavelength called the de Broglie wavelength. It is terms as lambda equals to h upon p, where h is the Planck constant and p is the momentum. When light shows high nature wave nature, it becomes large lambda. When the value of the wavelength is high, so it will show the wave nature, and vice versa for the particle. So if the smallest wavelength, so matter will show particle nature. Here is the de Broglie equation derivation. According to Planck's quantum relation, energy of a photon is quantized. That is equals to E equals to h nu, where nu is the frequency of the light and h is the Planck constant. Wave relation between frequency and wavelength. For a wave moving with velocity v, that is here we have taken velocity v equals to speed of light, that is c. So the frequency of the light will be nu equals to c upon lambda. Substituting the value of the c into the equation, we get equation E equals to hc upon lambda. Einstein's energy momentum relation for a photon, that is called as massless particle, the momentum is equals to E equals to energy E equals to momentum P into C. So equating both equation, because that is the equivalent energy of the quantum energy and the means momentum relation, Einstein's energy Pc must be equals to hc upon lambda. By solving the equation, cancelling c from the both side, we get the value p equals to h upon lambda, and rearranging lambda equals to h upon p, substituting the value for the momentum of the particle, that is p equals to mv. Then lambda equals to h upon mv. So if we plot the graph, so we can see that as the lambda decreases, p value of the momentum is increasing. Here from this graph you can see, as the lambda is increasing, so this means that p must be tends towards 0, so m lambda tends toward the infinity. And if the velocity or the speed of the light is tending toward infinity, then lambda should be tending towards 0. So these equations predict that this is very important equations, and from these equations we can know that how wavelength of the particles or wave nature of the particles depends upon the momentum of the particle. Thank you very much. Hope this is good for you, your understanding, and also deriving the equation of the de Broglie and how the particles so natures can be identified by only this equation. This is very simple mathematical equations. Thank you very much.